In this lecture, we are going to look at something called the absorptive versus post-absorptive states. The absorptive state is the time following a meal, and for this lecture, we are going to assume that the meal has carbohydrate, protein, and fat in it. And this is when we have the greatest nutrient absorption and the most nutrients entering our blood and our cells. The post-absorptive state is if you haven't had a meal in about 3 to 4 hours. So at this point, your blood nutrient levels have fallen and the body is relying on its reserves. Remember that we store glucose as glycogen in our skeletal muscle and the liver, and we also have an unlimited ability to store fat. We cannot store amino acids, however. In the previous lecture, you looked at the metabolic pathways for how the cells were able to use carbohydrate, lipid, or protein to either break it down for ATP production or to use it for anabolic processes. So in these two states, we are just going to explain this process a little bit more. So the absorptive state are the anabolic processes. So we're assuming that we've got lots of nutrients available. Now notice that you have a table in your notes, which I'll come back to shortly, but you can just take notes on that as I go over a couple things first. So as I said, absorptive, we're having anabolic processes. We are assuming that you ate carb, amino acids, protein, and lipid. And so when we take those foods in, they get broken down in our digestive tract and sent to cells. Now the cells can use all of those to build things. We have plenty of glucose available, so we're able to burn all that glucose to make ATP. And the liver's pretty active. Remember, all that blood gets to the liver through the hepatic portal vein. And so it's processing all that protein and all that lipid. So as we said, the timing, the absorptive is right after a meal, and the anabolic processes are going to be dominant. And so when we look at our foods, we're going to have our carbs and our fats and our proteins. Well, we just ate, so we're going to assume that there's plenty of glucose available. So that glucose is going to go into the cell. And when it enters the cell, there's 3 things that will happen to it. The very first thing, the priority, is the cell will use it for ATP production, because remember, glucose is terrific as a source of energy. Any extra glucose gets stored as glycogen. This was called glycogenesis, and this will be stored in the liver and in skeletal muscle. Now, if we still have extra glucose and we fill up our glycogen reserves, remember you can only store maybe 2,000, 2,200 calories, then you're going to convert it into fat. So it's called lipogenesis. And the liver will convert that glucose into lipid, and then it will send it out for storage. So you can gain weight and gain fat if you don't eat fat, because what happens is any extra carb you eat is going to get converted to fat. Now, let's say again, we have lipid in our meal. So we already know that the triglycerides get broken down into the glycerol and fatty acids. Remember, they get repackaged into that chylomicron. It enters your lymph and it travels until it hits the blood at the subclavian vein. Now, once that chylomicron enters the blood, the triglyceride part was broken off. That's what's sent to your cells, and your cells are going to use that triglyceride piece to make ATP. In fact, your fat cells, adipocytes, skeletal muscle, and hepatocytes prefer to burn lipid. So the more muscle you have, the more lipid you burn. Now, once you take off the triglyceride, the rest of that was called the remnant. And remember, that's going to go to the liver so it can process it into all the other lipoproteins that we'll be looking at shortly. The other thing that's going to happen is lots of lipogenesis. We had a meal, we have plenty of glucose to burn for ATP. So those fatty acids and glycerol and all those lipids, phospholipids, cholesterol, can also be used by cells to make things like steroid hormones like estrogen and testosterone. It can also be used to make cell membranes for growth and development. And remember that the steroid hormones are not just from the reproductive organs, from the gonads. They also come from the adrenal cortex. So cortisol is a steroid hormone, and so is aldosterone. So what about the proteins? Well, all those amino acids, right, that are absorbed go to the liver first. The liver is going to process them. It's going to use them to make plasma proteins and clotting proteins. And then the rest of those amino acids will be sent out to the cells of the body so that you can have your structural proteins that we learned about. You can have your enzymes, your antibodies, all of the proteins. So we have lots of anabolic activities. And so the hormone here is going to be insulin. Insulin is an anabolic hormone. And remember, if we're looking at blood glucose levels, we're going to use a wide range here. Let's say 70 to 120. I'll make it really big. It just depends on what book you look at. Sometimes it'll say 70 to 110. Sometimes it will say 80 to 120. So let's just do the whole thing. So if that's my normal blood glucose level, then when I eat, when I'm in the absorptive state, my blood glucose levels go up. Well, when my blood glucose levels go up, that's going to trigger the release of insulin. And insulin will come from the beta cells of the pancreas. So insulin's job is to open up the little glucose transporters so glucose can leave your blood and it can go ahead and enter the cells and be used, as we just said, up above. So it brings your glucose levels back down. So if your blood glucose levels, are above 120, as they go up, insulin will bring those levels back down. And again, we already said what would happen to all that glucose. And so when we look at insulin, insulin is a hypoglycemic hormone because we categorize the hormone based on what it does. And what it does is it lowers your blood glucose levels. And so if we look at it, again, everything you just saw is insulin. So when we eat, our blood glucose levels go up. That's the trigger for insulin. Insulin is going to get glucose into our cells where we can use it for ATP production, store it as glycogen, or store it as fat if there's extra. It gets our amino acids when they're in the blood. The cells will take up those amino acids where they can be used for protein synthesis. And it's going to trigger fat to go into the adipocytes, mainly for storage, but it causes lipogenesis. So it's an anabolic hormone. Now, what about that post-absorptive state? Well, the post-absorptive state, remember, is after 3 or 4 hours, so it's been several hours from a meal. Now, the concern if you haven't eaten is that your blood glucose levels are falling. So if your blood glucose levels should decrease, that's a problem because, the neurons and the red blood cells can only use glucose for energy. So we need to maintain our blood glucose levels. That's the goal of this step. And so we're going to have all catabolic processes. So now we're breaking everything down, right? We're going to take protein, triglycerides, and glycogen and break them down ultimately to get glucose. So we're going to be forming, trying to form glucose. And then anytime we have fast lipolysis, we learned about it in metabolism, we produce, anytime we burn fatty acids fast, we make those ketones. And then we're going to be breaking down those amino acids as well. So now we're taking everything out of storage because we need to maintain our blood glucose levels. So again, the timing is, 3 or 4 hours after a meal. And the processes here are going to be all catabolic processes that will occur. Now, what does that mean? Well, we're going to take our glycogen back out. We stored it in our liver and skeletal muscle. So now we do glycogenolysis, right? We're breaking it down. So we take glycogen, break it down into glucose, and put it out in the bloodstream so we can raise our blood glucose levels. This also happens in the skeletal muscle. It's just a little bit slower because it goes to pyruvate and then it goes to the liver. And the liver converts pyruvate to glucose. So, your liver stores about 400 kcals worth of glucose, of glycogen, which can be released as glucose. And that'll get you through a little bit. I mentioned before, if you've skipped a meal, you start to get hungry and you might get irritable. And then you might notice that the feeling passes and you kind of feel okay. And then it comes back even stronger. So that's your liver trying to maintain your blood glucose level. Now, as far as lipids, we're breaking fat down. We're breaking it down to make ATP, and we're going to break it down so that we can form glucose because that's the goal of this. Now, remember, we can use glycerol for glucose, not fatty acids. Fatty acids form those ketones and acetyl-CoA. So the glycerol can be converted to glucose. And so some tissues will actually switch over and they won't burn glucose for fuel. They'll burn fat. This is called glucose sparing. And your skeletal muscle and your liver are really good at doing this as well to burn more fat. Now the amino acids, we're breaking them down. So again, we're breaking them down for ATP because we're trying to spare the glucose for the cells that need it. And amino acids can be converted into glucose. And that's another example of gluconeogenesis. So if we come back now and we look at our blood glucose levels are falling during that post-absorptive state. Well, when they're falling, then that's a problem, right? It can be an emergency, in fact, because our neurons and our red blood cells need glucose. You might notice as your blood glucose levels fall, I mentioned you might get irritable, you might get a headache. If it continues, you might start to sweat, you might start to shake. It actually will send you into a crisis because if it falls too low, it can lead to seizures. So what's going to happen is when those glucose levels decrease, the pancreas is going to release glucagon. So my primary hormone is going to be glucagon. And so what it's going to do is all those catabolic processes we just looked at. It's going to break down glycogen, break down fat, break down protein, so it can bring your blood glucose levels back up. So glucagon is a hyperglycemic hormone because its job is to raise your blood glucose levels. Now, it is a true emergency, as I mentioned, if your blood glucose levels start to fall. So there's some other hormones that also can jump in. In fact, epinephrine and norepinephrine will jump in, as well as cortisol and even growth hormone, although growth hormone tends to work more like the glucose sparing. And so as I mentioned, as you get hungrier and hungrier, you might start to sweat. That's your fight or flight kicking in because it's an emergency. If your glucose levels fall too low, it can kill you. Your neurons have to have it. You might get shaky and jittery, and those are the effects of epi and norepi. So it can be a real crisis. And if you have patients who become severely hypoglycemic, they can be very combative. They're literally out of their mind because they don't really, their brains aren't working properly. And so there's you need to get glucose to them quickly. There's actually a type of paste that they can put sublingual to try to get that absorbed really, really fast. So if we look at the post-absorptive state and we look at now the glucagon release, now what we're doing is we're breaking everything down. We're taking everything out of storage because we're trying to maintain blood glucose levels. So we're going to break down our muscle protein. The liver is really involved here because it does all of these processes. So we're going to take proteins to amino acids, glycogen to glucose. We're going to break down fat. And the whole goal is a lot of that gluconeogenesis to make sure our brain gets the neurons, or excuse me, the neurons get the glucose. So we'll be breaking things down. Remember that when we have rapid lipolysis, we will get those ketones. Those ketone bodies, they're going to go to the kidneys to be eliminated in the urine. And if they accumulate too quickly, then we have a problem. We worry about ketoacidosis because it can change the pH of our blood. So when we're looking at these states, you'll see the two hormones we look at again are insulin and glucagon. They are antagonistic hormones, and their job is to maintain our normal blood glucose level. And you can see a summary here of when glucose levels go up, what insulin does to bring them back down, and we can see anytime our glucose levels fall, glucagon's job is to basically break it out of reserves to bring them back up. So what if there's a problem with your insulin? Well, diabetes mellitus is a condition with, I know you've heard of the disease, with issues with insulin. So mel means sweet, so often there is sugar in the urine because there's a problem with insulin. Remember, insulin's job was to get glucose out of the blood and into the cells. Well, if insulin isn't working well, you can't get the glucose out of the blood and into the cells. And so it ends up usually leaving in your urine. So a lot of times you're going to have what's called glucoseuria or glycosuria. You'll see it either way. So you're going to have this like sugar in the urine. It's the glucose. So what happens is when there's extra glucose in the urine, it pulls water out with it. So you pee a lot. That's polyuria. You might wake up several times during the night to urinate. If you're losing all that water, you have polydipsia, which is excessive thirst. In type 1, a lot of times there's excessive hunger, polyphagia, because they're not able to use the glucose for energy. The type 1 is called insulin dependent because the beta cells stop making it. So they just slowly stop making insulin. The type 2, they make insulin, but it doesn't work really well, so they tend to say you're insulin resistant. You can see the management is you need insulin if you're type 1. You might be on an insulin pump where they implant it in you and it automatically checks your blood glucose level to make sure that your insulin levels stay where they need to be. This one usually happens in younger individuals. With type 2, a lot of times you can manage it with diet and exercise. Exercise lowers your blood glucose levels. So if you exercise, they usually fall. So you have to be careful if you're taking insulin and you go exercise, you might have to adjust it. We also know that stress increases insulin. So if you are type 1 diabetic or type 2 and you're taking insulin, and I need to correct myself, stress increases glucose levels, which would require more insulin. So you want to keep an eye on your stress level as well. Your type 2 usually happen as you're older. They're both genetic. They both seem to possibly have an autoimmune component, especially type 1. And you can see some of the concerns if you have type 2. We worry a lot about circulation and wounds not healing really well. But, especially diet is important. Having a low glycemic diet, things that don't spike your blood glucose level, and having fiber are really helpful. As far as treatment, we just mentioned you might have to go on insulin. You can control it to some extent with diet and exercise because exercise works like insulin to lower your blood glucose level. And there's some new drugs that you've probably heard of that are out. They're these GLP-1 agonists. We're not going to go through everything the receptor does, but when you go on these meds, they actually help lower your blood glucose level. They're actually used for diabetics, especially type 2 diabetes or people who are insulin resistant. And they also found it really helps with weight loss as well. So you might have heard of some of these meds that are out. They're injections typically, but that's their mechanism. They can cause nausea, some GI things, but they seem to be really effective at lowering your insulin levels and also helping the patient lose weight. So this wraps up our lecture on the absorptive and post-absorptive stages.